academic background, and we will all certainly benefit from his presentations today. I just want to let you know that today's meeting is being recorded so that we can share that with additional participants who may be interested in hearing this talk afterwards. I'd like to encourage you to please put all of your questions in the Q&A, and you can go ahead and type those in, and Ronnie will be answering those at the end of the session. But feel free to put them in the chat as we're going so that you don't forget those questions. And with that, I'll turn it over to Ronnie, and thank you everyone for attending.
Thank you, Dan. Thank you everyone for joining today's session. Today's presentation is on the quality assurance of the transformer. So today's presentation is on the quality assurance of the transformer. So the first question comes, so why quality assurance? What's the reason behind the quality assurance, especially for the transformer? There are two main reasons for the transformer quality assurance. Number one is the operational reliability. Number two is the life expectancy of the transformer. The first thing comes about what's the operational reliability of the transformer. So when we procure the transformer, we have these things in our mind that we are procuring the transformer to put into service for 30, 40 years. But sometimes what happens that there can be repeated through fault or some other fault. Due to that, the transformer can be at fault and can be taken out from the service. And that's called the compromise of the operational reliability. So what I have done last 5-6 years is one of the things that I did is I did a survey with major electric utilities in United States and Canada. And what we found that most of the utilities are experiencing rise of repetitive fault. The reason behind that rise of repetitive fault is there's multidimensional reason. One of the reasons is that due to the change in the climate, now the trees are growing in certain way that is not following those tree trimming measures anymore. Besides that, the demand of power has been risen quite a bit. Because of that, the network is becoming more complex. Due to those complexity and change in the climate and all those things creating a pressure into the system and creating this rise into the repeated through fault. Due to that, the transformer are experiencing those repeated through fault in certain way, also experiencing the failure. Then I asked the people that when you are seeing this rise of repeated through fault, what it means to you, especially in your electrical infrastructure, when you have a critical infrastructure like transformer. What I gathered that especially those transformers that are built from mid-80s or before, those transformers are more well equipped to withstand those repetitive faults than those transformers that are built from mid-80s up until now. The question comes, why mid-80s is the year that we are targeting over here? The reason behind that is that before mid-80s, when the transformer was being designed, that time there's nothing called computer, there's nothing called sophisticated program to design the transformer. Because of that time the transformers that being designed are being over-designed and overbuilt. That means if you look at the transformer that are being built before mid-80s, they're heavy and bulky because they're being over-designed. Whereas from mid-80s, the transformer manufacturers started to use the computer program, sophisticated program, using the finite element method to know exactly the flux path. So that means they can be more aggressive into design. Because the manufacturer became more aggressive into design, but at the same time, they did not invest enough to improve the quality of the transformer factory, which is creating a lot of pressure on the quality of the transformer and compromising the operational reliability of the transformer. Then the next thing is the life of the transformer. What is the life expectancy of the transformer? The life of the transformer means the life of the insulation. Insulation is nothing but carbon-hydrogen chain. I'm a member of IEEE Transformers Committee. So one of my colleagues in IEEE Transformers Committee, who is a chemist, has done an extensive research on the life expectancy of the transformer. What he has proven through his experiment is that if you put the transformer into service for full load and running the transformer close to the all parameters, for example, maximum temperature 40 degrees C, average ambient temperature 65 degree rise, maximum average hotspot temperature 80 degree rise. When you are running that transformer close to those limits. In that case, the life of the transformer is 7 years. But in practical, we are seeing the life of the transformer much longer than that, 30 years, 40 years. The question comes, why you are getting 30, 40 years when my colleague at IEEE in his experiment proved that the life of the transformer is 7 years. The reason we are getting the life of the transformer 30, 40 years is because when we are putting the transformer into service, that time, the temperature is not, ambient temperature is not always 40 degrees C. The transformer internal temperature, let's say winding transformer, average winding transformer is not always 65 degrees C. The hotspot temperature is not always 80 degrees C. Due to that, we are gaining the life of the transformer. So now, as I talked about, one of the things that can compromise the quality of the transformer is the operational reliability, which due to the repeated through fault or many other electrical fault. Now, if when we are procuring the transformer, if we are not careful about the quality of the transformer, in that case, operational reliability can be compromised. Now, when it comes to the life of the transformer, as I talked about, is the life of the insulation. Insulation is nothing but carbon-hydrogen chain. Now, that carbon-hydrogen chain can be break down due to two reasons. One is the thermal reason, the other is the electrical reason. Now, during the manufacturing process, if something happened that blocking the oil channel, which can cause the rise of the temperature inside the transformer, in a way can compromise the quality of the transformer. Now, due to electrical means, let's say, for example, if you have a repeated through fault, then that through fault area can cause the rise of the temperature, which can cause the life of the transformer. In a way, you are losing the life of the transformer. So now we have established the two reasons that we need to be careful about when we are procuring the transformer is the reliability of the transformer, the life expectancy of the transformer. So now I will walk you through that what can be compromised during the manufacturing process that can cause the reliability and life of the transformer. Number one is the factory location. Does it really matter where the factory is located? Whether the factory is located in a dry area or wet area or humid area, whether the factory is located by the ocean or in the heartland. Of course, it matters. Why it matters? As I talked about transformer, inside the transformer, it has the insulation package. It is nothing but carbon-hydrogen chain. During the manufacturing process, if that carbon-hydrogen chain is exposed to the environment, especially humidity, in that case, it can absorb the moisture from the environment. If it absorbs the moisture, in that case, the manufacturer has to put this transformer into the vapor phase for a longer period. Longer period means is a cost of energy. Now, the cost of energy is not equal around the world. That means it's the extra cost for the manufacturer. The manufacturer has to be competitive in the market. Because he has to be competitive in the market, he has to cut the cost. If he has to cut the cost, one of the ways he will be cutting the cost is reducing the drying process. So that means if a factory is located into a dry area, it has a natural advantage over the factory that located into the humid area or wet area. Now the question comes, if the factory is located by the ocean, what happens is if a factory is located by the ocean, in that case, due to the vaporization, that salination from the ocean can land into the transformer, and in the long run, it can create an ionic path for the leakage current to follow. If it creates an ionic path for the leakage current to follow, in that case, it can cause the failure of the transformer. That means it is compromising the quality of the transformer. So, number one thing, it is very important the factory location, whether it is located in dry area or humid area. So now the question comes about the age of the factory, whether it's the old factory or newer factory. What happens if a factory is an old factory? In that case, it doesn't have enough space to install new equipment. Not only that, the factory manufacturing process, the layout is not conducive to the factory manufacturing process. Whereas new factory, it's built, the layout has been built thinking about how the manufacturing process can be smooth, and not only that, how the different compartment can be controlled. Over here, you can see the layout of an old factory. In this layout, you can see the winding area. Right across that winding area, you have that cold steel cutting area. Right across that cold steel cutting area, you have that cold stacking area. Right across it, you have tanking area. Now, this whole department, every single department, like winding area, cold steel cutting area, cold stacking area, everything is under one roof. Under one roof means each area is not separated from other area. Whereas this is the layout of a new factory. You can see in this layout, the winding area is separated from that core building area. The test bay is separated from the paint shop. And not only that, you can see the insulation shop is separated from the winding area, because by that way you can control each department. You see over here in this layout, if you want to go to the winding shop from the core building area, in that case you have to go through a door, and that door you can control, close and open to control the environment. Now the next question comes is the climate control of the factory. Does it really matter whether a factory is fully climate controlled, partially climate controlled, or no climate control? The first question is, what did I mean by the fully climate control? I meant by the fully climate control means controlling the humidity, controlling the temperature, controlling the iron filing or iron particles, and also controlling the dust. When I say partially controlled, that means certain area of the factory is being controlled. Now let's go back to the layout of the new factory. Over here, as you see, every single department is separated from the other department. So in this case, you can control the whole factory, from the humidity, from the temperature, from the metal particle, from the dust. Whereas if this factory is partially controlled, in that case, what you can do, you can control the humidity, temperature, the iron particle, and dust only in the winding area. So now, when I say no climate control, in that case, let's go back to this layout of the old factory. Over here, every single department, some like winding area, core steel cutting area, core stacking area, everything is under one roof. And there's no control of humidity, there's no control of temperature, there is no control of metal particle, there's no control of dust. So because there's no control, that means those can cause the compromise of the quality of the transformer. In that case, if the manufacturer is aggressive into the transformer design, in the long run, it can cause the failure of the transformer. So sometimes when you go to the factory, you can see there's a air shower. Now you have to make sure that the air shower is being used for every single person that enters into the factory to control the environment of the factory. So now inside the factory can be clean or no clean. So now the question comes, what is the cleanliness process? Does it really matter if a factory is clean or not? A study has been done and it says that a very clean factory can increase the reliability of the transformer by 4%. That means if you procure a transformer from a factory that is being very clean, that means right off the bat, you are getting almost 4% reliability out of it. Now the question comes about the cleaning approach. What are the cleaning approach into the factory that can improve the quality of the transformer? There is basically two major approach. One is all employees being part of the cleanliness process. The other one is cleaning process being outsourced to a third party. What is the problem of cleaning process being outsourced to the third party? The problem is those third parties, they are not being educated to how to do the cleaning of the factory. Not only that, they are not being educated on the importance of the cleanliness of the factory into the quality of the transformer. Sometimes what happens is that those cleaning companies, they have employees working in the transformer manufacturing factory for a month to clean the factory. Then the month after they go clean the airport, the month after they go clean the hospital. So now you have to understand that the cleaning the factory for the quality of the transformer is not same as cleaning the airport. It's not same as cleaning the hospital. So that means the better approach to keep the factory clean is if the all employees being part of the cleanliness process, which collectively can increase the quality of the transformer. Now, here is the manufacturing flowchart. I'll walk you through this flowchart. The first thing is when you are going to procure the transformer, what you do, you have your specification. You send out your specification to the manufacturer. The manufacturer look at the specification and provide you a proposal. You do the evaluation of the proposal commercially and technically. Once you evaluate the proposal, then you issue a PO. Once the manufacturer gets the PO, then what they do, they send this transformer spec to the design cell. In the design cell, it has two departments. One is electrical design cell and mechanical design cell. In the electrical design cell, they do the electrical design. The mechanical design cell, they do the mechanical design. Mechanical design has two parts, external design and internal design. So now, both electrical and mechanical design, it takes 6 weeks to 16 weeks, depending on the size of the transformer. So after 6 weeks to 16 weeks, let's say, for example, if you want to do the design review to ensure the design are being conservative and meet your system need, in that case, the design review process takes 3 weeks. After 3 weeks, what the manufacturer will do is you give the approval of the design to the manufacturer, then the manufacturer proceed with the procurement. Then when they will proceed with the procurement, they will procure the material. Once they procure the material will start to show up in the manufacturing factory. Once it starts to show up in the manufacturing factory, then the manufacturer, they will do inward inspection to control the quality. Once it has been, the material has been inspected, then the material is split into 2 sections and it will move, some material will move to the core building area, some material will move to the winding area. So what will move into the winding area is the conductor insulation package. And whereas the core steel will move into the core building area. So parallelly in the winding area, they will build the winding, they will wind the winding. At the same time, in the core building area, they will stack the core. Once they finish winding the coil, then they will put the coil into the oven to dry it up. After drying it up, they will apply the pressure to size the winding. At the same time, in the core building area, they will build the core. Once they size the winding and the core is ready, both the core and the winding will move into the core and coil assembly area, where they will nest the coil into the core. After nesting the coil into the core, then they will do the lead work. After doing the lead work, then they will put the transformer, we call it active part, into the drying area, into the vapor phase. In the vapor phase, depending on the size of the transformer and the location of the factory and the environment and whether the factory is climate controlled or not, in that case, this active part of the transformer can be into this vapor phase from 3 days to 10 days. Once it comes out of the vapor phase, then it will move into the tanking area. They will put the active part into the tank, then they will dress it and make it ready for the testing. Then the transformer will move into the testing area. And if it is being passed successfully into the testing area, then they will move that into the painting area. They will remove all those accessories, do the final touch up, then they will dispatch the transformer. This is basically the flow chart of the manufacturing process. Now I will walk you through in the factory and I will show you where the quality can be compromised. The first one is the procurement. So when it comes to the procurement of the material, basically there are 3 materials the manufacturer will procure: core steel, conductor, and insulation. When it comes to the core steel, the manufacturer can procure the core steel in 2 ways. One is pre-cut steel, the other one is the steel in bulk. I'll show you the picture. When it comes to the conductor, there is 4 types of conductors the manufacturer can procure. One is the conductor is paper insulated and enamel coated. The other conductor can be only paper insulated but no enamel coating. The other conductor can be only enamel coated but there is no paper insulation. And the final one can be bare conductor. Bare conductor means it doesn't have any paper insulation, it doesn't have any enamel coating. So now when it comes to the insulation, the manufacturer can buy the insulation in 2 ways. One is they can buy the insulation in bulk, or they can buy the insulation from the insulation supplier through a third party. That third party will cut the insulation. We call it pre-cut or pre-packaged insulation. Besides those materials, the manufacturer will procure tape changer, tank, frame, and all other materials, all other things. So now the picture that you see, it is an example of a pre-cut steel that the manufacturer gets from the steel supplier. So now here in the left-hand side, you can see the steel in a bulk in a roll. So basically what the manufacturer is doing, they are buying the steel in a bulk. Then they use this core cutting machine where they cut the steel for the core stacking. So let's go back to this old factory layout. Right over here, you see the winding area. If right across that winding area, there is no separation between the winding area and core steel cutting area. Just imagine you have this winding area where you are doing the winding, and the core steel cutting area, you have this core cutting machine. When you are cutting the core steel, that means you are creating that iron filing. When you are creating that iron filing, those iron filing can fly and land between the two turns in the winding. There is no test that you can pick it up into the factory acceptance test. The transformer will not gonna fail right away. Over the period in the long run, due to the dynamicism inside the transformer of the oil flow and all those things, in the long run, it can cause the failure of the transformer. That means you are compromising the quality of the transformer if the factory is something like this. So now here you see the type of conductors. On the left hand side, you have CTC, continuously transposed conductor. On the right hand side, you have that magnet wires, different kind of magnet wires that are being used in the transformer industry. The reason I'm showing you this conductor is because look at the conductor being wrapped with the gray thing. This gray thing is called insulation. This insulation is nothing but carbon hydrogen chain. This carbon hydrogen chain will absorb the moisture during the manufacturing process if the factory is not being climate controlled, which can compromise the quality of the transformer. Besides that, here you can see this is a conductor. The conductor has the insulation. The insulation comes in a layer. This conductor has one, two, three, four, five layer of insulation. So now here I have the experience of doing the design review for one of my clients. The client bought three transformers from the same manufacturer for last 5 years. The first transformer that we bought, that time the manufacturer was providing us 50 millimeter insulation. 3 years ago, when we bought the second transformer from the same manufacturer, the manufacturer moved from 50 millimeter to 45 millimeter. Now, last year, the beginning of last year, when we were buying the third transformer from the same manufacturer, the manufacturer gave us 40 mil. Just see, within 5 years, the manufacturer moved from 50 millimeter to 40 millimeter. That means reduced 10 millimeters into the insulation because the manufacturer became more aggressive into design. Because the manufacturer became more aggressive into design, but at the same time, what happened, the factory quality has not been improved. So that means the transformer is being stressed over here in terms of quality. Besides that, when the manufacturer will give us the insulation, this paper insulation, there can be different type of paper insulation. Here you see 1, 2, 3, 4, 5, 6, 7. There's 7 type of paper, crepe paper, craft paper. What type of paper the manufacturer will give to you and how much insulation the manufacturer will give to you, it depends on what is the manufacturer's design philosophy. Whether the manufacturer is taking 50 kV per millimeter for the breakdown voltage or 40 kV per millimeter for the breakdown voltage. That kind of gives an idea about the manufacturer is being aggressive into design or conservative into design. If the manufacturer is aggressive into design, in that case, those compromise of the quality during the manufacturing process can cost the reliability and the life of your transformer. So beside this paper, you have, this is, we call it key spacer. You see 1, 2, 3, 4, 5. There's 5 different type of key spacer. And those are nothing but carbon hydrogen chain that will absorb the moisture during the manufacturing process. Besides that, there's more carbon hydrogen chain. Let's look at the left side. Here, this one we call it duct stick. This one we call it riding block. This one we call it molded component. This one we call it line shield. This one we call it cooling ducts. Those are nothing but carbon hydrogen chain. This carbon hydrogen chain is the life of the transformer. So a month ago, what happened, one of my transformer failed to the factory acceptance test. The failure is because here you see the duct stick. This duct stick, I'll show you in the next picture. Here you see this duct stick. This duct stick, you see over here in this duct stick is being glued with the cylinder. When it's being glued, the glue has not been applied properly. Because it has not been applied properly, the glue had a bubble inside it. When dielectric test has been done, that bubble that the glue had, it kind of broke down. Because it broke down and it created partial discharge. So besides that, you see over here, you have end ring, you have key spacer, you have cylinder. All those things are nothing but carbon hydrogen chain. This carbon hydrogen chain is going to absorb the moisture during the manufacturing process. It can collect dust, it can collect metal particles, which can compromise the quality of your transformer. So now, this is an example of an insulation shop. let's go back to this layout that I showed over here. Right over here, if you see right over here, this insulation shop, right across this winding area. What is this insulation shop? In this insulation shop, what happens is if the manufacturer is not buying the insulation as a pre-cut or pre-packaged like this, what they do, they buy those insulation in bulk. They use this room, insulation shop. You can see this person is basically working on this room, cutting all those insulation for the insulation package. Just imagine, look at the floor. If the floor is not clean, if this room is not climate controlled, for example, if it's not controlled for humidity, if it's not controlled for dust, if it's not controlled for temperature, what's going to happen with this insulation? Insulation going to absorb the moisture, insulation going to absorb all those dust, and it's going to stay inside the transformer. And now think about if the manufacturer is being aggressive into design because the quality of the factory has not been improved, but at the same time manufacturer became aggressive into design. That means you are stressing your transformer. When you are putting the transformer into service, in that case, for simple failure, the transformer can have a catastrophic failure. Here is an example. On the left hand side, you see that the blue thing being wrapped. What's inside it? Inside is pre-cut steel. The pre-cut steel has been oil soaked and wrapped it properly so that when it is being shipped, in that case, due to monsoon, if it rains during the shipping time, it's not gonna be rusted. Not only that, it's not gonna collect any dust. Now on the right hand side, you see what happens is that this conductor reel is being shipped and there was a hole. And through this hole, what happened is that monsoon water got in and it contaminated the conductor. On the bottom one, you can see that core steel roll is lying on the factory and is being dented. Definitely, any of those things can compromise the quality of your transformer, which you cannot foresee. Right over here, you see there is a magnet. What I did, I went to the factory. I every time when I go to a factory, what I do, I take a magnet, I run it in the floor of the factory. Now you see all those metal particles picked up. The question comes, what this metal particle is coming from in this factory that gonna can compromise the quality of the transformer. If you look at very carefully in the factory, if you say at the top, at the roof of the factory, they have the crane which has not been maintained properly and it is running back and forth quite frequently to haul all those big transformers. What's happening is that those gears are wearing out and creating those iron filings, which is going to land inside the transformer and can cause the failure of the transformer in the long run. Maybe not in the factory acceptance test. So now let's go into the core building area. Top picture I have taken from an old factory where it doesn't have any modern equipment. What's happening is that they're using those support at the bottom where the core is being bended. Now at the bottom, the picture I have taken from a modern factory, new modern factory where they use this blue thing is called core stacking bed, modern core stacking bed. Just look at the difference. Look at the top picture and bottom picture. Look at the difference between these two core. The bottom picture, the core has been done very neatly, very clearly, very nicely. There's no scratch, no bending, nothing. While at the top one, the core has been bended. You don't know whether there's scratch or not, which is going to compromise the magnetic property of your transformer. So now over here, this picture I have taken from a factory. What happened? I went to the factory for core and coil inspection. Overnight it rained. Next morning when I went to the factory and the factory not being climate controlled and the humidity being high, what happened? The core got rusted. So now the rust is a killer for the transformer performance. Why? This rust is not be magnetically conductive, so it's gonna compromise the magnetic property of the core. That means it's gonna compromise the quality of the transformer. Now over here, the winding area. Let's move in the winding area. In the winding area, you can have a horizontal winding machine, you can have a vertical winding machine. It's better to have the vertical winding machine to wind your coil. The reason behind that is that in that case, you have the gravitational force G on your side to wind the conductor tightly against the cylinder. So now over here, I have two pictures, one from the old shop, one from the modern shop. Over here, the top picture is from the old shop where this individual is doing the winding using hand to wind the conductor against the cylinder. Whereas at the bottom picture, you see the conductor coming from the reel is going through a braking mechanism. After the braking mechanism is going through a socket. After that, you see from the braking mechanism, the conductor all the way to the cylinder is tightened. Not only that, on top of that, you have the tensioner. Because you have the braking mechanism and the tensioner, that means you can wind this conductor much tighter against the cylinder. Now, you may have a question is, why it is more important to have to wind this conductor much tighter against the cylinder? The reason behind that, when you put the transformer into service, if the transformer experience repeated through fault, in that case, fault means the fault current. When the fault current gets inside the transformer, the current creates that force, which is called short circuit force. There will be a huge short circuit force inside the transformer if it's not much tighter against the cylinder. If it is loose, in that case, the conductor will shake inside the transformer. When it will shake inside the transformer, then it will cause the failure. Here is an example of a vertical winding machine. On the left one, you see the vertical winding machine with the braking mechanism. On the right hand side, you see the vertical winding machine with the braking mechanism and tensioner. That means you will get the best quality out of your transformer if your winding has been winded using this vertical winding machine with the braking mechanism and tensioner. Why? Because in that case, the conductor will be much tighter against the cylinder. There will be no space. In that case, if you put the transformer into service due to for unseen reason, if the transformer faces any repeated through fault, in that case, the conductor will not have space to move around inside the transformer to cause the failure. So now, here you see on the left-hand side picture, the winding has been removed from the winding machine, and I was doing the inspection, and you see how much space there. So much space that even my pen can go through it. Because there is a space, what will happen in this space? If there is a repeated throw fault, in that case, this conductor will get the space to move around. If it gets the space to move around, in that case, it will cause the failure of the transformer. Now, on the right-hand side, you can see there is the duct stick sticking around on top of the winding. Why the duct stick is sticking around? So basically, when that winding was in the machine, that time I couldn't see those duct sticks. They were hiding underneath the conductor. So now what happens when they move this winding from the machine and put into the oven? When they put in the oven, they extract the moisture. When it came out of the oven, then they apply pressure to get the size of the winding. Once they got the size of the winding, in that case, the winding reduced 400 millimeters. You see that stick sticking around is 400 millimeters. That means you are reducing the winding 400 millimeters. When you are reducing the winding by 400 millimeters, that means mechanically you are loosening the winding. When you are mechanically loosening the winding, that means basically you are compromising the quality of the winding, which can cause the compromise of the quality of the transformer in the long run. So now on the left hand side, you create those coils. Then on the right hand side, you nest those coils into the core. Now look at it. If your factory is not being climate controlled, in that case, what will happen? Those core will absorb the moisture from the environment. And when you are trying to land in the core, it will be much tighter. Once you land it, then when you put it to the drying phase, in that case, it will extract the moisture. When it extracts the moisture, in that case, the coil will become loose against the core, against the cylinder. If it becomes loose against the core, against the cylinder, in that case, if the transformer experience repetitive fault or some other things, in that case, the transformer will fail. So now on the left hand side, you can see that person is doing the lead work using the old gas welding machine. When that person will use the gas welding machine, it's gonna create those flame. Not only flame, it can create also metal particle. If it creates those metal particle, it can cause the failure of the transformer in the long run. Whereas in the modern factory, they use induction machine. When you're using the induction machine for the lead work, you're not creating any fume, you're not creating any particle. That means you are not compromising the quality of the transformer. Now look at that, how big the transformer is. Here, all those great things are nothing but insulation. Just imagine you have this big transformer in a factory where the factory is not being climate controlled. it's not being controlled for humidity, it's not being controlled for temperature, it's not being controlled for dust, it's not being controlled for metal particles. So now it can absorb the moisture. Not only that, it can absorb the dust. It can have metal particles which can settle down inside the transformer, and in the long run, which can cause the failure of the transformer. So from this stage, the transformer will move into this stage, which we call it vapor phase. Vapor phase means is a big oven. This big transformer will be in this big oven. Again, depending on the location of the factory. If it is in a wet area, in that case, this transformer will be absorbing a lot of moisture. In that case, this transformer has to be in this chamber for, let's say, 4 days, 5 days, 6 days, 7 days, 8 days, 9 days, 10 days, depending on the size and how much moisture it has in the insulation. But the problem over here is that the manufacturer has to be competitive into the market. And in this chamber is being used the kerosene vapor and the electricity. So the electricity price is not same all over the world. So that means the energy cost will not be same for the manufacturer all around the world. And the manufacturer has to be competitive into market. If he has to be competitive into market, in that case, he has to think about to cut the cost. One of the ways that he can cut the cost is instead of putting this transformer in this vapor phase for 10 days, he's going to put, let's say, 7 days or 6 days to cut the cost. From there, they will dress it and the transformer will move into the testing bay for the factory acceptance test. So now there are many ways the transformer manufacturer can do the tricks so that the transformer can pass into the factory acceptance test. They can use very pure refined oil, which has a better dielectric property, not the same oil that will be used in the transformer in the site. They can control the environment of the factory testing bay so that even the manufacturer is aggressive in design, even though there is a contamination like dust, moisture inside the transformer is not going to fail because the manufacturer is doing the test using very pure refined oil and controlling the environment of the test bay. The environment of the test bay is not the same environment in the site, in the field. The next question is when you go to the factory, the manufacturer says that, oh, we have ISO certification. That's good that the manufacturer has ISO certification, but the manufacturer having ISO certification doesn't mean anything. You should go and check the factory. What are you going to do? First thing you're going to do is check, is there any check and balance into the QA/QC process? Is there any documented process? The QA/QC is being documented or not? How often the auditing is being done? Is there internal auditing or external auditing? If the auditing is being done, what they would do with this auditing result. The next thing is that I have seen going around the world, going to the factory. The factory is being resistant to issue any NCR or non-conformance report. One of the main reasons behind that, the factory thinks that if they issue too many NCR, in that case, whenever a client comes and sees too many NCR, they can think that the factory has a problem. But you have to think it in a different way. You have to think that, you know what, the factory is being serious. They are issuing the NCR and they are implementing those NCR reports to improve the quality of the factory, in a way, quality of the transformer. Besides that, the subcontractors, how they are maintaining the subcontractor, how they're controlling the quality of the subcontractor. Two things I'm going to point out over here that I'm experiencing around the world that can compromise the quality of the transformer. Number one is the tank. So what happens is most of the manufacturers, they don't build the tank anymore in-house. They outsource it to the third party. When they outsource it to the third party, they are not, the quality has not been maintained. So when the transformer goes into the site, in that case, one of the common failures that we are seeing lately is the tank leaking or tank rupture, especially the tank leaking. I can show you a couple pictures on that if we have time. The second problem is that the core, I showed you picture of pre-cut steel, core steel. So what's happening is that when the pre-cut core steel is coming from, let's say for example, the factory is located in London, UK, and the core steel is coming from Italy by shape. When it's coming through by shape, in that case, it's not being packaged properly, it's not being oil soaked, right? So during that process, what can happen that the quality of the steel can be compromised. So this Outsourcing, how the manufacturer is maintaining the quality of the subcontractors is becoming an issue, and which is compromising the quality of the transformer. The next question comes is the factory. The factory has what kind of training process for the employees? Do they have continuous training process, or do they have occasional training process, or do they have no training for the employees, so that the employees are not up to the level? At the same time, the employees having a refresher course to understand how to work collectively to increase the quality of the transformer. So yeah, now I'm going to share a few things that I have experienced around the world. Let's say, for example, England, being an industrialized country, has the long history of factories building things. For example, England has the history of building transformers for 100 years, have the history of building cars, let's say, for 50, 60 years. So when England has that history of 50, 60 years, that means England has done not only that qualified workforce, at the same time, they have a structured process. So that means when a factory is located in England, in that case, you can expect certain level of quality through the structured process. Whereas if a factory is located in a country that the country is not being part of the industrialized society, a country being a third world country or a agricultural society, never been factory there for 100 years or 50 years, in that case, you cannot expect same level of workforce there. Not only that, you cannot expect to have same level of structured quality control process. Not only that, there's also question comes about the work ethic. There's also question comes about the professionalism. Those things also can contribute to the compromise of the quality of the transformer. I'll give you one example. I have been to one factory where I picked up something in the factory and I brought it to the attention of the factory manager. And the factory manager kind of blamed me that it is not their fault. It doesn't compromise the quality. Whereas at the same time, I also have the experience of another factory where I brought out the problem to the factory manager, and factory manager thanked me bringing this to his attention and told me that he is going to keep me in the loop so that we can work together as a team so that they can improve the quality of the factory. So you see the two different approach. One approach is just blaming and not accepting the ideas, not listening. Whereas the other approach is appreciating, bringing those things and working together as a team to improve the factory quality. So those things can compromise the quality of the transformer. So now what can be the viable solution? Especially in United States and Canada, we look at three viable solutions. One is called factory auditing, the other one is called design review, third one we call it quality inspection during the manufacturing process. So now the factory auditing. What does the factory auditing means to us, especially in the United States and Canada, which I did not see that way in the rest of the world? Factory auditing means is when a manufacturer is going to provide transformer to us, we go to the factory, we look at the factory quality. It's not just checklist. We go to the engineering department, ask the question to understand what's their design philosophy, what then go into the factory, look at that factory, whether the factory is fully climate control or semi-climate control or no climate control. Look at the shop floor, is it clean or not? Those things we pointed out. So once we pointed out in the factory auditing report, the next thing what we do when we are procuring the transformer in the time after we issue the PO, that time we tell the manufacturer that once you finish the electrical design and mechanical design, you have to provide us the design to review the design. And you cannot procure any material. When I say any material means you cannot procure the conductor, you cannot procure the cold steel, you cannot procure the insulation package until we, the client, the purchaser of the transformer, review the design and approve the design. Once we approve the design, then the manufacturer can go ahead to procure all those materials for the manufacturing process. So now at the design review stage, what we look at whether the design is aggressive or not. If the factory quality is not good, let's say for example, if the factory is not fully climate controlled, if the factory floor is not clean, in that case, in the design, we try to force the manufacturer to be conservative, more conservative into the design. That's the whole purpose to ensure the quality of the transformer. And further, what the transformer manufacturer has been promised into the design stage to ensure those things have been implemented into the manufacturing process, what we do, We do the quality control inspection. We do core and coil inspection. We do coil nesting inspection in the core. We do pre-vapor fitting inspection. We do pre-tanking inspection. We do inspection during the factory acceptance test. And we also do inspection prior to the shipping. Now, you may have a question that, hey, Ronnie, implementing those process may cost. Let's say factory auditing gonna cost, doing the design review gonna cost, and having these 6 different inspections to the factory during the manufacturing process gonna cost. The question is that, let's say, if you try to implement those process into you, if you try to adopt those things that I talked about into your procurement process, it's gonna cost, let's say, 4 to 5% extra of your transformer. So now the question comes, this 4 to 5% extra cost is important to you, or the reliability of the transformer, the life of the transformer is important to you. If you want to procure a transformer which is gonna be reliable for 30, 40 years, that is you want, or you want a transformer, let's say, gonna last, let's say, 15, 20 years, and in the meantime, it's gonna give you a headache. So you need to do those cost analysis and see upfront this extra 4% cost to implement those procedures gonna create the comfort zone for you, or you want to live with an asset which is very critical for your infrastructure. So, so now, besides that, before I open up for the Q&A session, I'm gonna share a couple more things just so that you can have an idea about those things. One thing I'm gonna share over here is the specification. So I talked about that what happened is the design review that one of my clients procuring transformer for the same manufacturer for last 5 years for 3 transformers. 5 years ago, the manufacturer gave us 50 millimeter. 3 years ago, 45 millimeter, and last year gave us 40 millimeter into insulation. So now, in the next transformer, we're gonna do what we did in the specification. We're gonna put here the clause. All conductors, what we put over here, all conductor paper insulation CTC shall be at least 30 mils. So what we're gonna do is that now, when we're gonna procure the next transformer, when we do the design review, we'll force the manufacturer, look, we put in our specification that you have to put minimum this much insulation for our conductor. You just can go aggressive into design. Not only that, let's say, for example, over here, another thing that we put right over here in the specification that can force the manufacturer to be more conservative in the design, right over here, number C is that the maximum current density at the ONN rating shall not exceed 2 amps per square millimeter. What does it mean? It is forcing the manufacturer to be more conservative into thermal design so that the transformer is not being designed close to the temperature, which can cost the life of the transformer. So now what will happen in the design review stage, we will cross-check, we will force the manufacturer to implement those things. So our experience, what we learn over the period, dealing with the manufacturer, looking at the condition of the factory, as I said, technology has been improved. The design has been improved. The use of the modern technology, use of those sophisticated program, use of those fine-tuning method has enabled us to unleash a modern design, to be more aggressive into design, to be more compact design. But at the same time, the problem is there is not enough investment to improve the quality of the factory so that we can reap the fruits. That's what the problem is. So that's the whole purpose of today's presentation, is to kind of shed the light for you and to kind of open up your eyes that what can happen if you don't think about those factors that can cause the sufferings for you if you buy this transformer and put into service. So now I'm going to wrap it up and I'm going to open up if there's any questions.
Thank you, Ronnie, for the great presentation. And it looks like we do have one question already in the chat from Nan. He said, Dear Professor Minhaz, thank you for the excellent presentation. May I ask what the principles are when manufacturers balance lower costs and better quality of the transformers, or higher efficiency and lower loss? And how will these manufacturers deal with a transformer if it doesn't pass the type tests?
Okay, so the person that who asked that question looks like that person is not aware that when you procure the transformer, especially for the power level, power transformer, I would say, let's say, for example, transformer for the power grid, electrical grid. In that case, every transformer is custom designed. It's not off-the-shelf design. The transformer, every single time when you procure the transformer, it has to be custom designed depending on to meet the system need. When it's a system need, in that case, it has the impedance, it has the system parameters. And the system parameters varies from substation to substation. Because it varies from substation to substation, and the manufacturer has to do the custom design. So it's not the question of the efficiency. Transformer is a very efficient equipment into the electrical grid. The efficiency of the transformer is almost 99, more than 99%. So efficiency is not the problem. What the problem is, there's two things. Number one is the philosophy of your electrical utility. One of the big difference between the United States and England is United States is a big country full of natural resources, whereas England is a small island not blessed with natural resources. Because England is not blessed with natural resources, so for electrical companies in England, one of the main philosophy is how to reduce the loss. Whereas in United States, because it is big country and blessed with abundance of natural resources, in that case, for electric utility in United States, the loss is not an issue. So when it comes to the procurement of the transformer, the electrical utilities like from England or France or Germany, they more go after the manufacturer to reduce the loss. Whereas in United States, they don't go after loss. They go after more, let's say, dielectric property. They go after more thermal property. They go after more short circuit property. So when it comes to the quality of the transformer, the first question comes, what is the philosophy of myself when I'm going to procure the transformer? If loss is important to me, not other things, in that case, what happens is that when you go after the loss, sometimes you compromise other things. So first of all, you need to define yourself what I want. Do I want a transformer? There will be a balance with loss as well as balance with quality. In that case, what you'll do is that loss you can test it in the factory acceptance test. And when it comes to the type test, when you procure the transformer, it's not like you do the type test. Especially the only test is the type test, is the short circuit test. That's where the question comes over here, the philosophy of England and United States. In England, what they rely on, they ask the manufacturer, have you done the type test for this short circuit? Provide us a certification. So in England, they trust the manufacturer's certification. Whereas in United States, we don't trust on the certification from the laboratory. What we say that, you know what, because you are not invested to improve the quality of the manufacturing process, you have not been invested to improve the manufacturing process to go with your aggressiveness in design. In that case, we need to look into the design and review the design, which is a completely different philosophy from the UK or Europe. So I would say one of the things that Europe and England can learn from United States, if you want to follow that approach to balance between the loss and the quality, is to adopt some of those things. That's the way I think I can answer that question.
Thank you. It looks like we have a few more questions in the chat.
Sure.
And I think I'm going to start with the second question first, because it follows back up on what you just said. So the question is, where did you get that English or England is looking mainly to reduce losses, and is there evidences of that?
Well, if you see, let's say for example, England, they follow IEEE standard, whereas in United States, we follow IEEE standard. The second thing is when you look at the specification, it is called the loss evaluation. The third thing is that European it's called U mandate that came out in 2014. By 2021, so the mandate says that there is a two category. By August 2021, they have it. They call it peak. It's called peak efficiency index, which is basically based on the loss, right? Whereas in United States and Canada, what we do the loss evaluation. We say per kilowatt, how much loss. We do not follow this. Let's say, for example, currently I'm doing one project in Lithuania. I wrote the specification for Lithuania, lead grid. So, but there I have to follow this European Union mandate, where it says that it's called PEK, P-E-K, peak efficiency. I see peak efficiency index is called. So the manufacturer has to follow this peak efficiency index to provide the loss. So that's my experience, right? Again, as I said, England used to be part of EU, and one of the mandates from EU that they have to, all those countries are part of EU, they have to synchronize themselves. If they connect to interconnection with each other, they have to have the same system. In that case, they have to implement that EU mandate. And that EU mandate that came out 2014, signed by European Union President, came out of Vienna. That talks about the peak and loss.
Thank you. It looks like we have another question. So it's from M. Ahmad Farag. And he said, thank you for the presentation. How do you see location affecting transformer quality, although it is well manufactured and well sealed for moisture?
Well, again, here's the thing. If it is well maintained, sealed, in that case, the quality will not be compromised. The problem is that to maintain the factory well sealed, well maintained, it costs a lot of money. And at the same time, the manufacturer has to be competitive into market. What happens is these days, all those companies that procure the transformer, they don't have unlimited source of money. They have to look at the price of the transformer. When the moment they look into the price of the transformer, in that time, it becomes a price war. When it becomes a price war for the manufacturer, they have to look into ways how to cut the cost. So now the question comes, a factory is being well maintained, at the same time, the other factory is not being well maintained. In that case, if there is a huge cost difference, then why the manufacturer will try to keep the factory well maintained if he's not getting the project because the project is going under price? And this is my own experience. Let's say, for example, right now at this moment, I'm doing an evaluation for one project. There are 18 bidders for one transformer, 18 transformer manufacturers bidding for this project. Just imagine when 18 manufacturers is bidding for one transformer, how competitive the market is. And the transformer manufacturers are from Korea, from China, are from Mexico, are from Colombia, are from Poland, are from Spain, are from Croatia, are from Turkey, from all over the world. And the cost, labor cost is not same all over the world. The cost of electricity is not same all over the world because the drying process on those things, it costs money. So how can you compare apple to apple?
Makes sense. So it looks like we have another question in the chat from Rohan McGrath. And he has said, thank you for a great presentation. Do you have any advice for ensuring transformer quality for client organizations that will procure transformers as part of turnkey or EPC contracts, i.e. not procuring directly from the manufacturers?
Yes, well, the thing is that I used to work for a PCM company called Essential Labeling in Canada, which is one of the biggest electrical contractor in Canada. So, and during that period, I was in charge of the transformer. And to be honest with you, when the EPC contractor do any project, to them the quality doesn't matter. To them, all it matters is the hours. How many hours they can charge back to the client. And the thing is that when you buy critical infrastructure, something like a generator or a transformer, in that case, I would say there's no, I am not against to buy it as a turnkey using EPC contractors. What I want the user, the client, to sort out the legal documents that, hey, turnkey, when you are going to buy the turnkey or EPC contractor to procure this transformer, please make sure you are following these steps so that I can get a better transformer. Just don't let it lose the EPC contractors or the turnkey contractor. Don't let it loose. Don't put your full faith on them. Have some control over you so that you can monitor to ensure the quality of not only the transformer, anything. Because to be honest with you, my 3 years experience working for the EPC contractor, the EPC contractor model is nothing but how can I charge hours back to the client? Building up the charge, building up the hours, not the quality of the project.
That makes sense. So it sounds like it's important really to understand those specifications that you're passing on to those.
Exactly. So let me put it this way. When you are going to have a specification, when you are writing the specification, keep in mind in your head that when I'm going to write the specification, why I'm going to write the specification, what I want out of it. Let's say, for example, if you say that I'm going to procure the transformer that's going to last 30, 40 years and will give me reliable service, that means I have to write the specification in that way, thinking about that angle, that philosophy. Then you could say that, okay, what can compromise the reliability and the life of the transformer during this manufacturing process? How can I close these loops through specification, through EPC contractor, through turnkey contractor? Think about those before you proceed. Because let's say, for example, it is your money. Other people will not think about the same way that you will think about your own money. When you, let's say, for example, when you work hard, when you make your own money, when you are going to spend that money, even in the coffee shop, you think twice. But when it is someone else's money, you will not think twice.
So it looks like we do have another question from
Sure.
Ahmad Alzoayed. They've said, how are the aging factors determined in transformers, and what is the role as a manufacturer of the transformer in this concern?
Okay. The aging factor means, what is the aging factor of the transformer? Aging factor means aging of the insulation. What is insulation? Insulation is nothing but carbon hydrogen chain. So now, what can cause the aging of this carbon hydrogen chain? What can cause the life of this transformer? It is basically, in our term, in our industry, we call it polymerization. Polymerization of the carbon hydrogen. If the polymerization happens, what happens is two things happen. One is the insulation lose the strength, electrical strength. At the same time, it lose the property, right? You know. So there is no scientific method to measure the aging of the transformer. But what can cause the aging of the transformer? Two things. One is how you are loading the transformer, number one, and what is the amplitude of the loading. Number two is what is the environmental factor. Let's say, for example, if you are going to load the transformer, let's say 120%, for example, 120% for 6 hours for 4 days a week. And at the same time, if you are doing that in the summer, if your environmental temperature, let's say, is 30 degrees C, if you provide me those things, in that case, by using the IEEE guideline C57-120, I can do a rough calculation of what is the cost of, we call it loss of life. I can do the calculation of the loss of life of the transformer. So now, as I said, the loss of the life of the transformer is influenced by two things. Number one, your loading profile, how you are loading it over the period, the amplitude, the duration. The second thing is the environment, the factors, especially what is the temperature of the ambient, what is the temperature of the transformer inside, at what temperature the transformer has been designed. If you know those factors, in that case, you can slow down the aging of the transformer, the aging factor of the transformer. Now, from the manufacturing point of view, how this aging factor can come. One of the things that aging factor is happening is, as I said, carbon-hydrogen chain. This carbon-hydrogen chain, if it absorbs the moisture, what will happen? That H2O will be linked into the carbon-hydrogen chain. When it gets linked to the carbon-hydrogen chain, in that time, that the insulation gradually loses its property. So from the manufacturer side, you have to make sure that it has been dried properly. Not only that dried properly, during the manufacturing process, the insulation has not been absorbed any moisture, well, it can have a chemical composition with that carbon-hydrogen chain, which can contribute to that aging factor.
Great. Well, thank you so much for answering all the questions and the wonderful presentation. It looks like there are no other additional questions in the Q&A. So if no one has further questions, we'll go ahead and wrap up today's presentation. On behalf of the IEEE PES chapter of the UK and Ireland and the student branch at the University of Birmingham, we'd like to thank you for your great presentation today. Thank you everyone for attending. And we do encourage you to continue to participate in further IEEE events in the future. And thank you so much, Ronnie, for your time.
Yeah, thank you everyone for the opportunity to do the presentation. And in future, if anyone have any question related to transformer, here is my email address. They can shoot me an email. If the question is not coming at this moment, later on, if the question comes, definitely I will answer that question. And at the same time, I have more presentations. Maybe in future, if possible to do in person, maybe we can do a presentation on transformer design, basically how to do the design of the transformer, which is a very interesting presentation.
Well, thank you so much.
Well, everyone have a good night then.